So the world is facing a number of challenges. Many of those challenges will be solved by engineers. At the same time, aerospace engineering is facing a very exciting future. The advent of electric and hybrid propulsion and unmanned vehicles in particular present many different opportunities, and we're going to need aerospace engineers to harness that potential. Within the programmes we cover a lot of different subjects. The students will have exercises on wind tunnels, they'll look at material properties, they'll stretch and break materials. They can expect to use our active learning laboratory to do some of their design work. The students can use the virtual engine test bench, which is a simulation of a jet engine without the hassle of actually having to run a jet engine.
It's all well and good being in a lecture and learning sort of like what lift is or what drag is or what stall is, but until you've actually been inside a simulator or in a real aircraft, you don't get a good appreciation of what these things actually are.
The two motion-based simulators that we have are probably unique in an academic environment.
It's great for consolidating knowledge, consolidating theory that might be hard to grasp until you've seen it practically.
We run engineering capstone design projects, which is the students' opportunity to demonstrate all that they've learned embodied in an engineering artefact. They either build a simulation model of a full-scale aircraft, which we then get test pilots to test in our simulation facility, or it ends in a design, build and test of an unmanned aerial vehicle, which we try and get the students to enter competitions.
Behind me is the 2017 entry into the Heavy and Electric Lift Challenge. The idea of the competition is to carry a maximum of 4 kilos of water over a given distance.
When the aircraft flies for the first time, I'm not looking at the aircraft because I know it will fly. I'm looking at the students, and it's the look on their faces where they realise that what they're doing is real and has value. That's why I enjoy teaching.
In your second year, you'll do something called a flight test course. It's in a jet stream, I think it's 32 aircraft.
The students go and spend a day experiencing real flight testing, collecting data, and then they'll come back and write a report.
You're actually sitting there and feeling it in real time, experiencing it. So it feels a bit like a roller coaster. It's a lot of fun. And it's just a great way, again, to consolidate that theoretical knowledge.
When I graduated and went into industry, it took me 18 months to stop thinking, that's what they were talking about in lectures. The aim of active learning is to get the students to still learn the theory that they need to learn, but to apply it very early in their degree course. So right from year one, they're doing design, build, test exercises.
In second year, you do a module aimed at getting you into full group work. What the project for us this year was, we were designing a non-returnable drone for humanitarian relief. The amazing thing about the project was that it gave so much room for innovation and new ideas, and it let you experience what engineering actually is in terms of coming up with a solution to a problem that's not necessarily been tackled before.
We offer courses with pilot studies, and this is a degree for people who think they might want to be pilots but want a good engineering degree to back up their career choices.
And that's what the Pilot Studies Lab is tailored towards. It's an area for pilot studies students to come in to learn the theory behind the course. But then also in the Pilot Studies Lab, so not necessarily just for pilot studies students, we've got 3 fixed-base simulators.
Our Pilot Studies Lab is a student-led activity that is certainly unique, probably globally.
It's not members of staff saying we need this, this and this done. It's a case of students seeing an issue with the simulators or a potential upgrade for the simulators and saying, I want to do this, can I do this? As long as it's a viable idea, as long as we can use it, then we'll do it.
When you compare Liverpool to other universities, you'll find that Liverpool has more hands-on experience. I had the opportunity to see the theory that I've learned in a lecture room be actually used in the real world.
Much of our research is based in rotary wing aircraft, so helicopters, tilt rotor aircraft and so on. That flavours our courses in the sense that the students are exposed to not only fixed wing aircraft as they would be on many other courses, but also vertical lift technology, which is one of the areas that's becoming very exciting in aerospace engineering at the moment.
You get a lot of universities where everything can be quite sprawled out. You need to sort of walk very long distances or actually even get the bus sometimes to different places, whereas everything in Liverpool is really well contained.
The city is very friendly and it's very compact as well.
I really just feel it was a university that was, while being research oriented, really for undergraduates, really wanting to push undergraduate access for everything. So that's why I chose Liverpool.
An engineering degree is valuable in many respects. One is you learn the key technical skills around engineering, but in addition you learn lots of skills that are useful to other employers, such as report writing, being able to present, you're numerate, you can solve problems, and all of these qualities of an engineer are valuable across the employment sectors.